Let's talk about these. The first is this concept of inter-reader reliability, or you could call it inter-observer agreement. So anytime you have more than one person scoring something, essentially what gets used statistically to look at the relationship between the scores of the two readers are these coefficients. The R, the Pearson R correlation coefficient, and that is used for interval and ratio measures. This is why I mentioned why levels of measurement are so important, because they're going to keep popping up now, from now until the end, because they determine what statistics you can use. The Pearson R is used for interval and ratio level measures, and this is a kappa, and kappa is used for categorical measures. And I'm going to give you an example in just one moment. So categorical measures are nominally measured and ordinally measured. Okay, I'm going to show you an example, I think in the next slide. So let's talk about, that's supposed to be test. Test, retest. So you can measure reliability of a test by calculating the R, which is the correlation, the Pearson correlation between the test and the retest. If you have, let's say I wanted to test the critical thinking gains of our students with the ACT CAP critical thinking test. So I could come in when those students first arrive on campus and administer the ACT CAP critical thinking test to the new students on campus. That's my pre-test, let's say. And then let's say they go through their 3 years at the college, and I want to find out how much they've learned in terms of critical thinking. I might re-administer the ACT CAP test as a retest or a post-test, or I might administer a different test like the learning assessment, collegiate learning assessment. And I think for community colleges it's called the Community College Collegiate Learning Assessment. There might be 3 C's in it. And so I could measure the reliability of these two measures by calculating the Pearson R between the two sets of scores. This will be a set of scores, and this would be a set of scores. Finally, internal consistency is about the degree to which different parts of a test intended to measure the same thing actually do measure the same thing. So if you create like an index for student or employee engagement, and you have 10 questions that are measuring that concept of engagement, or for ease of writing on the tablet, let's just say 5. We have 5 survey questions that are intended to measure employee engagement. I would use this measure of internal consistency to understand how well these items are hanging together as a measure for engagement. You actually have to assess that. And that's measured by this Greek letter, and that's called the Cronbach's alpha. Cronbach's alpha. And that's what's used to measure internal consistency of items that are used to create a scale or an index. CRONBACH. Cronbach's alpha. It essentially generates an average correlation, and that R is a correlation, between each of the items that you're using, all pairs of items. Cronbach's alpha ranges from 0 to 1, with 1 meaning perfect internal consistency. An acceptable alpha is 0.7. So generally, like for our employee engagement survey, we had an engagement index, and I wanted to make sure that all the items hung together. And so I was looking for a Cronbach's alpha of at least 0.7 or above. If you don't have the 0.7, you might be able to alter what's in the questions that are in the index to try to improve the internal consistency. The results should provide how each item contributes to the total score. And so even, let's say, this was less than 0.7 by using these 5 questions. I'll show you this example later. If I took one out because it's not a very good measure of engagement, the other 4 might hang together better, in which case the alpha would go up. And that's what we want, a high alpha. The Pearson's R ranges from -1 to +1. And the 1s on either side indicates a strong correlation. A 0 indicates no correlation. So this is how you can actually measure reliability with statistics. And these are the statistics to use, but we're going to show you how a little bit later. So in terms of an example, this is a measure for critical thinking. It is a rubric designed to be used to apply to student work to measure critical thinking. And what you can see on here is that a piece of student work could get a score across these capabilities of anywhere from a 0 to a 3. So with score number 1, they could give, let's say, a 1 on this capability, a 2 on this capability, a 3 on this capability, and a 2 on this capability, so that we have a total score of 3, 6, 8. And then the next reader could come in without looking at these numbers and give, let's say, a score of 2 and a score of 1 and a score of 0 and a score of 1 for a total score of 4. Well, let's say you had 500 pieces of student work, and these 2 readers were going through and they were giving all these scores. And so you would essentially have 500 scores from reader number 1 and 500 scores from reader number 2. Because the possible range on this rubric is basically from 0 to 12, because we have 4 capabilities and the max possible number would be 3 for each one. So the max here would be 12 points from 0 to 12. I would use the R, the Pearson's R, to check the reliability between the 2 readers. This ends this part of the module's presentation. Please move on
to review the next part